So hey guys, welcome back, and today we are going to start a new playlist on sliding window techniques where we are going to cover each and every pattern that could come up while solving any kind of sliding window problems on any kind of like on GFZ lead code, wherever you want. There could be like 6 to 7 pattern in every type of sliding window techniques, right? So we will going to cover each and every patterns that can come up while solving sliding window techniques. And one more thing, before starting, I would also code it in Python. So whatever language you are comfortable with, you can convert in that, but for now we are going to code in Python actually. So because it feels like it's more like a pseudocode, so that's why I chosen the Python. Okay, and the second thing is, like, in sliding window there could be thousand of the questions, but we are not going to solve thousand of the question. What we will do instead, we will only focus on the patterns, right? We will only focus on the patterns, because it's not possible for us to solve 1000 of the questions. So that's why we will follow the patterns, right? Before starting, like, I would say that I will also tell you my experience while solving these kind of pattern, because sometimes what happens is sometimes questions also gives you some keywords, so you must be able to recognize, like, this could be a sliding window problems and all these things. So don't worry, I will explain each and everything step by step. So what happens is, like, in sliding window, before moving further, you might not be able to understand what exactly the sliding window is. So let me tell you what happens. Like, so suppose sliding window is only applicable like whenever we are given with some array, or like we are given some string actually, right? String. And the second keyword is this is input, so this must be input like array or string. And the second thing is, like, the question must be talking about some substring type of thing, substring, or sometimes it must talk about subarray, right? So if there is something like substring or subarray or array or string, you must be able to think of, you must be able to relate it, like there could be some sliding window questions inside of it, right? So whenever the question talks about array or string or sometimes substring or subarray, you should at least give a try like sliding window. You should think of sliding window once, right? And the second thing is, like, what exactly substring and subarray is. You are, like, I suppose that you already know, but let me just explain what exactly subarray or substring is. So what happens, let's say I have given an array, or I have given some string like a b c d e f, something like that, or 1 2 3 4 5, let's say, right? So what happens, what subarray is, like, I can pick any like I can pick any certain amount of elements continuously, so that would be our substring, right? Or what I can do is, let's say I took these 4 elements, so these are our substring and these are our subarray. So whenever it applied on array, it's subarray, or whenever it applied on string, it is substring, right? And the second thing is, there is also a subsequence as well. So what happens in subsequence, I'm explaining because there should not be any confusion in substring or subarray or subsequence. Let's say I have given an 1 2 3 4 5, this is an array. So what happens is, let's say I took like 1 2 3, right? So this is our subarray, this is our subarray, right? And if I take 1 2 4, so this is our subsequence. Why subsequence? Because we skip 3, but we managed to have the order, like this is 1, this is 2, and this is 3. It will keep coming. So in subsequence we can skip elements, but we should preserve the order, like the first 1 came, then 2, and then 3, then 4, then 5. So the order of the array must be preserved, but we can skip elements in it. So these are subsequence and these are subarray, right? So I think substring and subarray are clear. Now moving to the sliding window part, right? So in sliding window, what we do is, in sliding window, in sliding window we would have two kind of thing. The first one is fixed size sliding window. I will come up after a second. So the second one would be variable size sliding window, right? So what exactly is window means, or what exactly the size of window or kind of thing, right? So let's say I have given, first we have to understand the window, right? What exactly the window is. So whenever we talk about window, we ultimately are talking about substring or subarray. So window means substring or subarray, right? And the second thing is what is size. What is size? When I say that fixed size, or when I say the variable size, what exactly that means? So let's say, like, I have also given one more time, I have given an array. Let's say I have given 1 2 3 and 4 and 5, something like that. And let's say I took two pointers, like I here and j here. Here I equal to 1 and here j equal to 3. So if someone asks me if this pointer is at I is at 2 and j is at 4, what is the size of window? What is the size of window? Size of window. So size of window ultimately means the size of subarray, and that is also means that size of substring. Okay, so now what is the size of window, or what is the size of subarray, or what is the size of substring? So if I have given I and j starting and ending of the subarray, right? So what we have to do, we have to just j minus I plus 1. If I do this, I will get the size of subarray, or size of substring, or size of window, right? So I hope this is clear. How did it come it, like j minus I plus 1? If I do so, it comes to 3. So that means we have here 3 elements, 1 2 3. So the number of elements is same as the size of window. The number of elements means that size of subarray or substring, right? Okay, now moving further, in the fixed size sliding window we have almost like 6 to 7 patterns, and based on that patterns we can further divided some more problems on that. Some standard lead code problems we will also come on that. And in the variable size sliding window, these are pretty much same. Like in variable size sliding window we have almost here as well 6 to 7 patterns, right? We will also cover that in our upcoming videos, right? Now, so one more thing you should keep in mind, you can pause this video and you can keep a note that whenever the key takeaway here so far is whenever subarray, whenever question talks about subarray, substring or window, kind of window, then you must think of, like, you must think of sliding window first, right? Sliding window, that there should be a trigger in your mind that this could be a sliding window problem, right? And the second thing is okay, coming to that point, before I will say that in variable size sliding window and fixed size sliding window, in the fixed size sliding window I should be given the window size. Okay, in the variable size sliding window, we have to find the window size. Here window size is not given. Instead, we would be given some conditions. Based on that condition, we need to find the window size. Okay, so we will cover this variable size window in our upcoming videos. So here we are starting off by fixed size sliding window, right? So I should say fixed size sliding window, right? Fixed size sliding window. Okay, So what is the sliding window means? That let's once think that what is sliding window, right? Let's say I have given an array 2 5 1, let's say 8 2 9 and 1. Okay, so this is an array, and let's say the question says that I have to return maximum sum subarray of size, let's say size 3, subarray size 3. So this is an subarray, this is also a subarray, this is also a subarray, right? So this is a subarray. So what I meant by that, so if I take this thing, this is a subarray of size 3, right? So if this I take this thing, this is a subarray of size 3. And now the question says that I have to return the maximum sum subarray, right? So in this case, the maximum sum subarray would be like this, 8 to 9. If I add 8 plus 2 plus 9, I get 19 here. This is 19. If I take this subarray, I would get somewhere like 5 to 7, 8. So I think this is pretty much clear that the maximum sum would be 19. My question is, how can we solve it? Right? How can we solve it? How can we solve it? Of course, the first thing what you can do is that you can take 3 loops and you can pretty much solve it. Start the first loop. That is not the thing sliding window is made for. Sliding window is made to optimize things, right? So how would we do that? Let's see. Okay, what I will do, this is sliding window is kind of very efficient approach. I will tell you how and how sliding window works. Okay, in sliding window what we do is we first start by taking 2 pointers. I will take I equal to 0 and j equal to 0. So we start by taking 2 pointers, and the both pointers will be at at the starting position. So this is I and this is j. So these are at the I equal to 0. Now what we do is we are given that we have to get a subarray of size 3. Okay, at this point, if I equal to 0 and j equal to 0, could you tell me that what is the size of subarray right now? If I do j minus I plus 1 kind of thing, you could pretty much see that this is a 0, right? And what I will do, I will keep increasing it. Now what we do is we need to find the subarray of size 3. So what we will do, we will keep increasing any of the pointer. For convention, I will increase the j pointers, right? Okay, and I have to track the maximum sum, right? I have to track the maximum sum. So what I will do, I will make a variable here, sum equal to, for now, 0, right? Now what I will do, I will increase this pointer from this to this. So I'm starting with increasing the pointer j, right? I will keep the pointer I and I will keep the pointer j. So I will increase the j every time. So how I'm going to do is, let's say initially it will be like this. Okay, so if the j is at 0, what I will do, I will I will also take a pointer, let's say answer equal to 0, and this answer will store my maximum sum so far, right? This will store my maximum sum, and this sum will be like a temporary sum, right? This sum will be like a temporary sum. Okay, now what I'm going to do is, like, for now j is at 0. So if j is at 0, before increasing this pointer j, I will add up that value of j equal to 0, right? So at initially point, this will be at j equal to 0. So answer would be plus 2, because here the value is 2. So now after adding this sum is equal to 2, I will keep increasing until I get a subarray of size 3. So now I increase at this point. Now I will add up 5 as well, plus 5, and now at this point j would be like 1, and now our subarray size is here 2, right? And now we have to pretty much find a subarray size of 3. So we haven't found yet, so we will again increase that. So how I'm going to do it, I will increase j one more time. I will increase j one more time. That's kind of pretty frustrating. I will increase j one more time, and now I am j at here. Now I will first do, I will add up, and now I will add up, and my j will be at this point. My j will be at this point. Okay, so at this point my sum is like 5 to 7 plus 1, that is 8. So my temporary sum is 8, and we also found a subarray of size 3 at this point. So as we've got a subarray of size 3, I will what I will do, I will assign this 8 to here, that is maximum sum. So this will be like 8. Okay, now we got the first subarray, but there are a lot of subarray. What I'm going to do that in that case? So what I'm going to do, I will again increase this j, right? I will again increase this j. Okay, but now our subarray size became 4. But what we have to do here, we have to find the subarray size of 3. But what I'm going to do, if I increase j, if I increase j from here to here, our subarray size will be 4. Subarray size will be 4. So in that case, I have to increase this I as well to make this subarray another subarray of size 3. So in that case, what I will do is, first I have to increase this I, and before increasing I have to remove this element from our sum, because this element is not a part of our current subarray when I increase this I pointer from, if this increase this I pointer from this to this, after increasing this this 2 element will not be a part of our sum. So for that reason I have to decrease it, and that will become 6, and now I can freely increase this pointer I from I equal to 0 to I equal to 1. So I'm going to do that. So now I will be here. Okay, and now you can see that our subarray are, if this j is here, I have to also increase the j size. So for that reason I have to also increase this j. So our j will be at this point. Now our j will be moved. As we increase the j, now again we have to add this a point array of j to our sum. So we will increase our sum by the array of j. Now I'm going to write as this way, and this will be 6 plus 8, and that came out to be like 14. Now this 14, now the check is start. Our I is at 1 and j is at our 3, right? Now again, if I see that I again hit the subarray size of 3, right? When I hit the subarray size of 3, I need to update our maximum sum. Previously the maximum sum was 8, and now I found out to be 14. So I will again update this 8 with 14. So let's do that. 14. And now the second iteration. Okay, so now we will increase this j pointer. So if I increase this j pointer, I will our subarray size again will be 4. So for that reason I will I don't want my subarray to become 4, because I have already given that my size of subarray must be 3. So for that reason I have to again increase this I to keep our window maintained. So in order to increase this pointer I have to again decrease this value from our sum, because after increasing I, this value won't be a part of our subarray. So this must be also removed from the sum, because this sum tracks the current sum of our subarray, right? So that's why I will also decrease this 5 from here, and I will get the 9, right? I will get the 9. So right now this I would be here, this I would be at this point. Now our right now currently j is at this point, so right now you see that our subarray size, window size is again less than 3, so we have to again increase the I, increase the j. So for that reason I will increase the j again, and this came out here. Now as I increase the j, I have to also add the value here, and I got 11, right? I got 11, and after increasing I will check, did we hit the window size? So we again hit the window size. So what I'm going to do, I'm going to update our maximum sum. So we right now the current window sum is 11 and maximum was 14. So do we need to update it? No, we don't need to update it, so we won't update. So now after we decide that we won't update, then we need to switch to another window. To switch another window, what I will do, I will again increase the pointer I and pointer j. To increase the pointer I, what I will do, I will switch this j. Hold on. So I will increase this I. How I'm going to do it, I'm going to switch, oh my god, I'm going to pick this value from here to here, and before increasing the value I will decrease this value, because this value is not a part of subarray, so I will decrease that value. So 11 minus 1, that becomes 10. So our I is here, j is here, so current window size is 2 here, current window size is 2 here, and the current window sum is 10 here, right? Current window sum is 10 here, you can see here. Now the current window size is 2, so we want to hit the window size 3, so we again less than the size, so we again increase this j pointer. So now we came to here. Now as we increase the j, we need to again increase our window size. If we increase the window size, we have to again sum it up to our current sum. So the current sum was 10 plus 9, and that becomes 19. The current window sum is 19, and now we also hit the window size, that is 3, so we need to update it. So we updated, and that came up to 19, right? That came up to 19, and again we will hit this window, so we will increase that. So I hope that you got the idea. So the pattern I will write here, right? So I will pattern right here. So general format of the sliding window for the fixed sliding window is, what the fixed sliding window is, we will be given the window size that should need to be hit. Window size, we will be given the window size, we will be given some array, we will be given some array, or we will be given some string, and the question must be asked for some subarray kind of thing or some substring kind of thing, right? Like return the first negative number in the every subarray, return the maximum sum of subarray, return the first letter of the substring, kind of things, right? Whenever the question talks about substring or subarray, we first think of sliding window. Okay, so the format for fixed side sliding window will be, I will take 2 pointers, I equal to 0, j equal to 0. Okay, so I will also take a answer kind of variable, let's say whatever it could be for now, and what I will do, I will increase while j is less than length of array, right? I will add up in our temporary current window variable, that is let's say let's name it as, let's say a current window sum, right? Current window sum, let's say that is 0. I'm giving it a long name because so that it's so intuitive to understand. So what I will do, I will append current window sum equal to current we can also write it as like plus equal to or array of j, and then if a window size, what window size means, j minus I plus 1. If window size is less than our given window size, if let's say that is k, so if the window size j minus I plus 1 is less than k, I need to keep increasing our window size, right? j plus equal to 1. And if elif our j minus I plus 1, that is window size, hit the window size k, then what I will do, I will first update the answer. So I will first update the answer equal to let's write as something like this: update answer, and then in sort I will say maintain window size, maintain window size. What maintain window size means, I'm talking about like I have to increase I plus equal to 1, I have to increase j plus equal to 1, and before increasing I need to remove the last element, because we are increasing I, as we told you that we are increasing I, so this last pointer will not be a part of our subarray, so it must be removed from the current window calculation, right? Because initially I was here, so we increased I here, so this element won't be part of our current window, so this must be removed from current window calculation. So to do that, what I will do, so this is the name of the current window sum, so current window sum minus equal to array of I, and now I can increase array I, now I can increase pointer I and pointer j. So this is pretty much our code. So this is actually a general format of a fixed size sliding window. You can pretty much see that this is our general format of our sliding window. This is our general format of sliding window. Keep in mind, before solving any sliding window, you should keep in mind that how actually we code our sliding window, right? So how in this case how we update the answer, we update the answer by answer equal to max of answer and current window sum, right? So and at the end, after as while loop exit, we can return the answer. So this is pseudocode, or you can convert it any programming language, whatever you want. So this is pretty much everything. Okay, and do you think, okay, one more point, do you think sliding our window size would ever exceed, because we hadn't written any kind of condition if our sliding window exceed the k value, that is our given subarray size or given window size, would it ever exceed the value k? No, it would never exceed the value k. Why? Because every time we hit the window, we increase one pointer, we decrease one pointer, right? We increase the size from one side, we decrease the size of one side, so it would never increase from that initial length, right? So that's why we don't have to check where if ever the window size exceed the value k, so it would never exceed the value k. So in the next video, what I'm going to do, in the next video I'm going to solve a pretty much very popular sliding window problem that even appeared in InfinityQ many times. So that is, the question name is find first negative integer in every window size, in every subarray, of size, let's say k. So in the next video we are going to solve this problem using the same pattern, without any extra knowledge. We will solve this problem using the same pattern, right? So if you have any doubt, if you have any question, feel free to comment that and I will definitely answer it out. Thanks for watching this video. Have a nice day.